1.2, day 2 of the chapter. I'm Mr. Bishop, and today we're talking about rate of change. And then using math notation, that's delta y over delta x, delta being that triangle thing. So a quick note, if you haven't seen that before in any other classes, it's a Greek letter. It just represents change. And so more specifically, we're going to look at the average rate of change. And really that's just a fancy way to say slope, which I think we're all familiar with at this point. So we typically use m as our variable for slope. So slope m, you've probably heard it being called rise over run, which should make sense if we think about changes in the y's, because the y-axis runs vertically up and down, over changes in the x, that runs right left. So the rise over the run. And then the famous formula, the difference in the y's over the difference in the x's, y2 minus y1 over x2 minus x1. So those are just points. And as long as we keep them in order, it doesn't really matter which point is point 1 and which point is point 2. So this idea of getting 2 points and finding the slope, that goes back to Algebra 1. But remember, we don't typically use the y's when we use pre-calc notation. We use function notation. So instead of xy, we use x f of x. So it might look something like this in function notation. x1 f of x1. That's our point. And then x2 f of x2. So you're comfortable replacing y with f of x. Now we just have it in the form of coordinate points, x f of x. And we can use those same exact points to plug into our slope equation. Instead of using the y's, we can use f of x. So let's look at example 1 here. I got a point A, f of A, and B, f of B. Now I know those aren't numbers, but you should get the general idea just from what we talked about a moment ago with x f of x. So I give you 2 points, and you probably know what I'm going to ask. What's the rate of change between those 2 points? I'm going to abbreviate here, ROC. I'm essentially asking what's the slope between those 2 points. So you've got the values, and you know the equation. So it's the changes in the y's divided by the change in the x's. So on top, if this is the y, f of b, minus the other y, which is f of a, over, to make sure your order's correct, should say b minus a, and not the other way around. And that's actually it for this example. There's nothing further we can do. I'm going to go ahead and give this one a little cloud. That's it. We can just set that up and put it into the slope equation, and we're done. We don't have any further values to evaluate with. So that's also maybe something a little bit new about pre-calc. I can ask you to evaluate these with just variables, right? Just letters. You don't actually have any numbers. You can just set up the formula. Let's go ahead and look at example 2. Little cross-country scenario. The first part, in 2013, 55 people ran cross-country, aka XC. That's cross-country. In 2015, 80 people were on the cross-country team. So then the natural question here would be, what's the average rate of change? Being, how much did the cross-country team change on average every year? I know the difference. I could easily subtract and find the difference between 2015 and 2013, but I want to know on average for each year, what was the average change? So again, that's just a really fancy way to ask a simple question. What's the slope between 2 points? So we just need to start by identifying which one's the independent and which one's the dependent. So in other words, which one's the x variable and which one's the y variable. Well, in most all cases, time, in this case it'd be years, that's independent. Time is pretty much independent of everything. And then the size of the team, that depends on the year. That depends on the time. So in our case, independent is going to be time, or the years, and then the XC people on the team, that's going to be the dependent variable. So now we know which ones are X's and which ones are our Y's. So if this is an X for the years and this is the Y for the people on the team, we can actually take this information and make points out of it, and then we can find the slope. So 2013, 55 would be 1 point, and 2015, 80 would be the other point. So our slope, remember we subtract the y's on top, so 80 minus 55 on top, or you could do 55 minus 80, not going to matter here, as long as we keep things in order. And then since we did 80 first on top, we'll do 2015 minus 2013 on bottom, which should give us 25 over 2. Now another really important distinction we need to make for pre-calc. What the heck would the units be on this? I'm finding average rate of change in what units? So on top, the y values, we said those were people on the team. And on bottom, we said this was years. So that's people per year. 25 people for every 2 years. 25 over 2 is 12.5. So what are the units on this? The average rate of change, 12.5 people per year. So units are important here. We're able to put people on top, years on the bottom, and then once we divide, we get 12.5 people per year. And does that look like an increase or a decrease? The fact that it's positive tells me it's probably an increase. And now the most important part, the new part for pre-calculus is, can you interpret that answer? Can you describe what that means? So let's get a little quote here. So on average, that's an important piece, the team grows by 12.5 people every year. And there's my little extra credit cross-country runner right there. The cross-country figure, not so important. What is important is, once you get this answer, can you determine what it means? It doesn't mean every year for sure it grows by 12.5 people. It could be different from year to year. This is actually an average. So the average rate of change in this case, on average, the team grows by 12.5 people every year. All right, let's take a look at example 3. We're going to start by making a table, and we're going to compare the populations of your 2 favorite cities, perhaps, Chicago and New York. And this is actual data we're using here. Chicago and NYC, their populations in different years. So we're going to do 91, 2000, 2010, and 2015. So then the numbers for Chicago, 2.79, 2.90, 2.70, and 2.72. Remember, these are in millions. And then for NYC, 7.3, 8.02, 8.19, and 8.41. So then I just have a couple questions about the 2 cities here. Part A. What's the average rate of change in Chicago's population on the interval from 2000 to 2015? So remember, average rate of change is just a fancy way to say slope. So what's the slope from these 2 points, from 2000 to 2015? So all you got to do is identify 2 points, like on a graph, and we can find the slope. So 2000 and 2015. There we go. Let's look at those first. Don't worry about any of the other stuff on the table. If we're finding slope, we just need to identify those 2 points. So I'll use M for rate of change. That's the slope. So on top, let's subtract the populations. Those are our Y variable. And remember, we already talked about time. That's always going to be our X variable. That's always going to be the independent variable. So on the bottom, we'll subtract 2015 minus 2000. So we've got our 2 points, 2000, 2.90, 2015, 2.72. Oops, 2.92. That's no good. That's supposed to be 2.90. Let me update that. The math should be all good now. Subtract on top, subtract on bottom, and then when we divide here, negative 0.012. And then what are the units for that, since this is average rate of change? We're looking at million people per year. So we had millions of people on top, years on the bottom, after we divide our average rate of change between 2000 and 2015. negative 0.012 million people per year. Okay, and then for part B, I want to ask a similar question about New York City. I want to know what's the average rate of change in New York City's population on the interval from 91 to 2010. Notice I don't want to rewrite that whole problem again, so I just put quote marks for the stuff that was going to be the same. So let's get 2 points, find the slope from 91 to 2010 for New York City. So let's focus in on, there we go, 91, 7.30 million, and then 2010, 8.19 million. So let's go ahead and set that up. Slope M equals, so on top we're going to subtract those population numbers, 8.19 minus 7.30, and then on bottom let's subtract the years that they correspond with. So it goes 2010 minus 1991. Should give us 0.89 over 19. So they increased 0.89 million people over 19 years. Let's divide that and get an answer of 0.047. That's million people per year. So New York, over that time span on average, increasing by that much. Chicago, over this time span, on average, decreasing by that much. It is totally fine to leave these in these weird decimals and say million people per year. That's the units you were given, so you don't have to convert that to like thousands or hundreds of thousands of people. You can leave it just like this and use the units you were given, which is million people per year. All right, for the next example here, example 4, we're going to start by making a really simple graph. So let's start by drawing some axes, and then you can go out a few tick marks in each direction. And then I'm going to go ahead and put some points down here. So negative 2, 0, negative 1, 2, 2, negative 2, and 3, 0. And then let's go ahead and just make a sketch here. This is going to represent our function f. So really just a crude graph connecting those dots, and that's the graph of our function f. We don't know the formula for it or anything, we just have a graph. And then I want to know, what's the average rate of change from x equals negative 1 to x equals 2? So we have a graph, question about average rate of change, really just a fancy word for slope. But to find the slope, we need 2 points. So where are we at on this graph when x equals negative 1, and where are we at when x equals 2? So if I can map that over, x equals negative 1, I'm up here somewhere. And then when x equals 2, I'm down here somewhere. So we need to grab the values, those 2 coordinate points, we need to grab those and find the slope between those two. So negative 1 and 2. The height would be f of negative 1 right here. That would be the height for that one. The height for this one, f of 2, would be right here. So for negative 1, looks like we're at negative 1 comma 2. Right? The height would be 2. That's that point. And then for f of 2, the height down here, f of 2, looks like that's at negative 2. So not so bad. We just use this information to grab 2 points off the graph. What's the average rate of change from x equals negative 1 to x equals 2? Well, you grab the y values, so you got the points. Now just find the slope. So on top, subtract the y's. On bottom, subtract the x's. Should get negative 4 over 3. And that's good enough. That's a reduced fraction. That's our answer. So what does that mean? Looks like it goes down 4 units every time it goes over 3 units, right? Because this is rise over run. So it goes down 4 on the y, and then over 3 on the x. So the fact that this is negative, a negative slope between these 2 points, we can say that this is, the function is decreasing on the interval from negative 1 to 2. This isn't a point, this is an interval, right? With brackets, open brackets, closed brackets. This function would be decreasing from negative 1 to 2, right? And we can kind of see that. I mean, it's going straight down. So a negative slope between 2 points means that the function was decreasing. Okay, example 5, there's only 6 examples for these notes, only 6. I'm going to start by just giving you the formula for a function, f of x equals x squared plus 3. And then I want you to find the AROC, the average rate of change from x equals 1 to x equals 5. Again, I'm just asking you a slope question. Average rate of change is a fancy way to say slope. But to have slope, you need an xy coordinate point. Right now we only have half a point here and half a point here. We got to get those full coordinate points out. So let's think it's increasing, right? This is an increasing function. In fact, you probably know that this makes a parabola. We could make a really crude sketch of this thing. It's a parabola that's shifted up 3 units because of that +3 right there. So from 1 to 5, the average rate of change, it should be increasing in value. So x equals 1 to x equals 5. Can we get points on that graph? Well, yeah, we can. We just plug in 1 for x and we plug in 5 for x, and we can easily get those points. And once we have those values, we find the slope. Really, what we're finding is that little dotted line, like a straight line between those 2 points. The question is, what's the slope between those 2 points? 1 comma whatever this is, 5 comma whatever this is. We could find the slope of that little dotted line. So let's start with plug in 1 to this function. The output should be 4, right? 1 squared is 1, plus 3, you get 4. You plug in 5, you get 28. 5 squared is 25, plus 3. So we have these 2 points, 1, 4, and 5, 28. What's the average rate of change? So just find the slope, subtract the y's on top, subtract the x's on bottom. Should give us a positive answer if you did it correctly, 24 over 4, which is 6. So it's an increasing function. Looks like it would be up 6 over 1 on average for this line. The reason being is because between this point and this point, we went up 24 and over 4. So on average, that's up 6 for every 1 unit over, rise over run. So again, the fact that this is positive, that means that the function was increasing on this interval from x equals 1 to x equals 5. It was increasing. We had a positive value for the average rate of change. So that's an increasing function on that interval alone. Would it be decreasing on a different interval? Yeah, looks like it could be. But for this one, it was increasing. So for problems like these, you didn't really have to draw a graph. You didn't really have to know this. All you had to do was plug in x equals 1 to get the y value, and then plug in x equals 5 to get that y value, and use those 2 points to find the slope. That's really all that was required on this question. I just tried to illustrate it a little bit. Let's look at example 6 here, our last example. I'm going to give you a couple important points. I'm going to tell you h of x is some function. In fact, h of x is an increasing function. So that's all the information I'm going to start you off with. H of x, I could have called it f of x or g of x, whatever. I called it h of x. It's an increasing function. So I want to know, just off that little bit of information, is the average rate of change, or the slope, from x equals -2 to x equals 3, is that going to be positive or negative? What do you think? So you may already have a pretty good guess, and you may even have some reasoning behind this one. It's an increasing function, so is the slope from when x equals -2 to when x equals 3 going to be positive or negative, the average rate of change? And maybe you're able to visualize this in your head. I like to go ahead and make a really rough sketch. I have no idea what h of x actually looks like, but if it's an increasing function, I mean, I can draw a really basic increasing function. How about this? Here's a straight line that's going up from left to right. That's an increasing function. I just made that up, right? I don't know if that's how it looks in reality, but that's going to work for now. Some increasing function. And then let's think about where you would be. If that's an increasing function, where would you be for x equals -2 and x equals 3? Well, here's x equals -2, so there's some point. We don't know exactly where it is. And here's x equals 3, so that's another point. We don't know exactly where it is. But in relation to each other, we can get a pretty good idea. So if we started to calculate the slope, and maybe you already know the answer, right? Maybe you know it's going to be whether it's a positive number or negative number, but if we start to use the formula to calculate it, m equals, so we subtract the y's on top and the x's on bottom. Now I don't know exactly what the y's are going to be, so I just put the question marks there. But the x's, I know I have 3, and then I have a -2. So I'm going to use that order. But here's the thing, and I'll actually color code this for you. This will be the purple question mark up here, and this will be the red question mark down here. we know for sure that on the bottom, we're going to have 5, right? 3 minus negative 2 is going to be 5. But I want to know what's the difference going to be with these y values. Well, if we did in this order, for sure, up here with the 3, this one is a greater value than this one, right? In fact, this one will be positive, and this one will be negative. So this question mark up here would definitely be bigger than this one. So what happens when you take a bigger number and you subtract a smaller number from it? What kind of numbers do you get? Well, you should get a positive number on top, right? Bigger number minus a smaller number. In this case, we're looking to get a positive number over 5. So this question mark up here, this height is a bigger number. Subtract away from it, this question mark height is a smaller number. So we know we have a positive number on top. And what's any positive number divided by 5? Our answer is going to be positive. So do you have to do it like this? Do you have to think about it like this? No. All you have to do is make some sort of comparison and think, if I'm going from negative 2 to 3, and it's an increasing function, is the average rate of change going to be positive or negative? And on this one, it's got to be positive because we're increasing. And we proved it, bigger number minus smaller number on top. So this one's positive. Okay, last piece here, part B. Is h of 7 minus h of 4 positive or negative? Same exact scenario. We're using the same function, h of x. All we know is that it's an increasing function. So h of 7 minus h of 4, would that be positive or negative, you think? So again, I'm not exactly sure how this looks, but I can make a really rough sketch of some increasing function, right? So just some increasing function. There you go, rough sketch. And then where would h of 7 be? What value? And then how about h of 4? What would those values be? So really important thing to remember here. These values are the outputs. These are the things you would get if you plugged in 7 to the function. Those are your answers. Or if you plugged in 4. We're not looking for 4 specifically or 7 specifically. We know how to subtract 7 and 4. We want to know h of 7 and h of 4. We want to map those out really quickly. So here's 4 and here's 7 on the x-axis. I want to know their heights, their output values. So let's start with 4. If we can map that over, go up, plug in 4, how high are we on the graph? So we're at 4 here. The height would be h of 4. That's what we're interested in. So my point right here would be 4 comma h of 4. The input's 4, the height would be h of 4. And then for 7, I plug in 7. Let's go up and then map it over. The height would be h of 7. So for that point on the graph, it would be 7 comma h of 7. So what would we get? If you subtracted h of 7 minus h of 4, is that a positive or a negative answer? Well, let's see. H of 7 minus h of 4. Apparently, h of 7 is a bigger number, right? Because it's higher up on the y-axis here. H of 7 is a bigger number. So if we do a bigger number minus a smaller number, that answer is going to be, for sure, every time, positive. All right, that is all for these notes. Average rate of change, really fancy way to say slope. We looked at it from a few different angles. I'll see you in class.